All right. So, I don't know, again, whatever class you came from, I'm trying to make a transition from that class to chemistry. Do you remember the demonstration yesterday and what part of it said that didn't make sense or what part did make sense? So let me just have some input here. What's something you saw yesterday it did make sense to you? What's something you remember? Anybody? Something you remembered? Todd, I haven't called you for a long time. What's something you remember?
Violet has the highest.
Violet has now. Even though that wasn't in the demonstration, did you ever see a violet light? When you were looking at the spectroscope, did you see any emission spectrums that were violet? Okay, so what that means, look at here, what does that mean on your right? That means that the violet light came from the biggest quantum jump. So electrons were being excited, and some of them might got excited up to this level, maybe up to this level, maybe up to that level. And then when they come back down, they don't have to go all the way back down. They can come partially down, can't they? And then they might go back up, and they might go and so the combination of one element's electrons are already in a certain ground state. They're in a certain position. And then they're excited, they go like that. And then they give off these different lights. And I'm hoping you understand that that's like a fingerprint. Like you can actually identify an element like that. If you were interested in another extra credit project, I mentioned one to you, but another one would be like this weekend. Let's say you want to take a spectroscope. You want to check a spectroscope out. You could go to different places. Like some neighborhoods have street lights that look very dingy. Does anybody live in a neighborhood where the lights are not that bright? The street lights are kind of yellowish or dingy. Have you ever seen that? In some states, like California, that's the only kind of street lights you can have. They had passed a law because there were so many bright lights coming from the city. It was they called it light pollution. And light pollution means you couldn't even see the stars very well. And so they passed laws. Some places passed law where you can only use those. Well, if you were to take the spectroscope and look at that street light, you would see it would give off a certain band of color. And you could actually just write that down on a piece of paper, and then maybe you look at, I have that chart back there, and I think you would find that it matched pretty closely to sodium, because those are called sodium vapor lights. They actually vaporize sodium to a gas. It's in a container, and they excite it. You could also try a street light that looks kind of bright and see what you get there. You could go to the gym. The gym has these really bright lights, and that'll give a different signature. And that's called mercury vapor. They have mercury vapor in them. That's why they can't just take those bulbs and crack them open like that. So they have to dispose of them probably a different way. You could also go, yes, it would look a little weird, but it's for science. You could go to grocery stores and find out what kind of light is shining on the produce, or what kind of light is shining on the meat section. Is the light on the meat section, that's given a different color than, did they do it on purpose? Are they doing that? And they are. They actually do that on purpose. So anyway, if you thought you'd like to say that, just let me know. And this weekend would be a great weekend if you want to do it. If you want to do it later, you can. But I certainly could check out a spectroscope to you like that. Okay. So you okay with that, the demonstration, all that? Now, what we get into today, let's talk about, I think we've talked about 4 scientists so far, haven't we? All right. We won't be the only other scientist in here. This right here, we'll get to him in just a minute. And then there's another one that is not written in the book, and I always have you write the name in the book. Here it is, Hund's rule. We'll talk about that. And that might be all the scientists that there would be. Okay. So now, what I gave you is a little packet. He said, wow, he gave me another periodic table. I think I have 5 or 6 of them. Okay, well, this one is a little different. If you'll take a look, let's look at lithium. How many electrons would a lithium atom have? And everybody should know that. What is that? Well, it's not number one on the periodic table, so I bet it's not going to be one. I bet Olivia knows. How many electrons does every lithium atom have? Three. Isn't that why it's number three? It has 3 protons, right? It's number 3 because it has 3 protons, and if it's a neutral atom, it has to have 3 electrons, doesn't it? So if you're not an ion, gadolinium has 64 protons and 64 electrons, doesn't it? Are you okay with that? Are you okay? All right. Hey, Will, can you put your head up, please? You can sleep during lunch if you want. Anyway, so lithium has 3 electrons, right? And we talked about this yesterday. Where would you put 3 electrons if you were a lithium atom? They say, well, you always put it in the lowest energy level first. So I'm going to put it in energy level number 1. Okay. And where are you going to put it in level 1? Well, there's this place, and it looks kind of like a ball. It's a probability map, and it's called an s orbital. Is everybody looking at me? So in the first energy level, there's a place called an s orbital. How many electrons can you put in any orbital at the most? Everybody in here should know. You're right. I only mentioned it once yesterday, but how many electrons can go in any orbital? 2. All right. So you're lithium. You have 3 electrons, right? Go to the first energy level and put 1 in the s. Can you put another one in that s? Yes. Okay. Now, can you put a third one in there? No. Orbitals can only hold 2. Well, is there another orbital in the first energy level? No, there's not. Oh, then I guess I'm going to have to go to the second energy level. In the second energy level, is there a probability zone or a place where it also looks like a sphere? Is it also like an s orbital? Is there a 2s? Yes. Matter of fact, every energy level, and there are 7 energy levels, I know that because there are 7 periods in the periodic table. Every energy level has an S. 1s, 2s, 3s, 4s, okay? Now, if you're lithium, you're going to put 2 in the first energy level, and you're going to put 1 in the second energy level. And that makes sense to me because why are there only 2 elements in the first period? They're the only elements that only need 1 energy level to put their electrons in there. If you have at least 1 electron in that energy level, you're in that period. So who is the first element to need a second energy level? It has to be lithium because the first one's full. It can only hold 2. So lithium has its 3rd electron in the second energy level. Where in the second energy level? In an s orbital. Yes?
So in every energy level, they can only hold 2.
No, but in every energy level, if it's an s orbital, it can hold 2. Okay, so we'll get to some of the other orbitals today, okay? So now let's take a look. What if you were hydrogen? If you're hydrogen, you only have 1 electron. Where are you going to put it? And this is called the electron configuration for hydrogen. In the first energy level, in an s orbital, I put 1. That's where my 1 electron is. It's a 1s1 electron. Okay. What if you're helium? Well, helium has 2. Where are you going to put them? Hey, you know what? I found out you can put both electrons in an s orbital in level 1 also, 1s2. Are you with me? All right. Let's do lithium. Lithium, hey, lithium, you got 3. What are you going to do with your first 2? Are you crazy? I'm going to do the same thing helium did. Why wouldn't I? Why wouldn't I put the first 2 the same place helium did? So I do. 1s2. Hey, you got another one, though. Yeah, you're right. It won't fit in the first energy level. I have to go to the second energy level, and there's an orbital area. Oh, not 1s, but what? 2s. And I only have 1 more, so there it is. 2 plus 1 is 3 electrons. That's it. What's the electron configuration for lithium? Everybody say it? 1s2, 2s1. Hey, we're going to do this all day. We're going to do this all day, and they're going to get better and better and better, okay? Now, so the periodic table I gave you, look right there. Look where it says lithium. And what does it say underneath the number 3? 2, 1. What do you think they mean there? 2 in the first energy level, 1 in the second. Look at beryllium. What's it say? 2, 2. 2 in the first energy level, 2 in the second. Okay. Now, so here's what's interesting. And you can make a little chart. I started a chart in the book here. And I actually like their chart too. I'm going to use theirs for a minute. Okay, in the first energy level, there's only one kind of orbital. It's an s orbital. There it is. And any orbital can only hold 2 electrons at the most. I got it. Let's go to the second energy level, which is bigger. It's a higher energy level. It's more volume. It can handle more electrons. We find there's also an s orbital. It's got that shape. But then we find something kind of weird. And I didn't do it. It's this probability map says there's another orbital that's shaped like a dumbbell, or kind of like a funny figure 8, and it's oriented this way. And there's another dumbbell, another p orbital, like that. Another one like that. Now again, let's relax a little bit. The first energy level only has an s orbital. That's all. The second has s and p. S and p orbitals. It only has one s, but there are 3 ways to be a p orbital. Okay, now stay with me, okay? Because when you start connecting this with that right there, then you become a really good chemistry student. You already are. But you're going to even be a better one after you make these connections. All right. So imagine this. Let's go ahead and do beryllium. What would berylliums do that? You do it before I write down. You write down beryllium's electron configuration before I do. Ready? Go. Beryllium, you have 4 electrons. What are you going to do with your first 2? Silly. I do what everybody else except hydrogen does. 1s2. What are you going to do with the next 2? Well, I'm going to go to the second energy level, and I have to go into S first. I'll put 2 of those there. 2 plus 2, that's 4 electrons. That was easy. And then something strange happens. Something strange happens. Notice that we jump from this part of the periodic table all the way over to here. And actually, you're doing something different. That's why it's over there. Something strange is going to happen here. Let's do the next element over here called boron. Now, just relax and let this happen, okay? Just let it happen. If we do this 20 times a day, you'll understand it. You get it? I don't care if you don't understand it right now. Just keep with it, and we'll do it 20 times. You'll say, well, now I get it. All right, if you had 5 electrons, what would you do with them? Well, in the first energy level, in the s orbital, I put 2. That's what everybody does except hydrogen. He only has 1. What are you going to do with the next 2? Well, you kidding me? I'll do what beryllium did. And I can't put more than 2 in there anyway. But now, where do I go now? Can I put some more in the second energy level? Yes, but not in an s orbital. You have to go to what? A 2p orbital. I'm still in the second energy level, but not an S-shaped orbital, but P-shaped. And how many are you going to put in there? Let's see, boron only has 5, so there you go. Yes? All right. What's the next element? Let's do carbon. How many electrons does carbon have? 6. Okay. What are you going to do with 6 electrons? Okay. Act like you own a electron parking deck, and you want to have the most efficient parking deck you can. And so you say, hey, let's say you got 6 electrons. I'm putting your first one in a 1s orbital. I'm putting your second one there too. So I'm putting the first 2, 1s2. There you go. So 2 of the 6 cars have been parked. And you say, the next car says, I want to be in the first level. Sorry, it's full. First level's full. You got to go, your car's got to go in the second level. Well, where is it going to be in the second level? It'll be in an s orbital, and y'all put 2 of those there. There's 4 of your 6 electrons, right? But the next car says, I want to be in the second s orbital. No, you can't. You can't. It's full. You can only put 2 in an orbital. But in the second deck of the parking deck, in a different kind of parking space called a P, I'll put 2. What do you think about that? Is that pretty easy? All right. Let's see you do one. Do one by yourself. Do nitrogen next. Do nitrogen next. Do you need a pencil? Everybody try this, because I'm okay if you make a mistake. We're just starting this, so I'm all right with that. But I want everybody to actually write these out and get used to saying 1s2, 2s2, 2p2, something like that. All right, let me call on, how about Claire Nettles? What do you got, Claire?
1s2, 2s2, and then 2p3.
Yeah, what do you think? Let's count them up. 3 plus 2 plus 2, that's 7. And that's how many electrons nitrogen has. Hey, I think I've got this. Let's do the next element. Okay, do oxygen. Yes.
I don't really understand like how to find this. Like I don't get how to do it.
Okay, that's fine. So we'll start over again. So what we do is, let's say, how many electrons does every oxygen atom have? How many? So
9 or
it's number 8. It's on number 8. Oxygen is number 8. See, 8 means you have 8 protons. And if you have 8 protons and you're a neutral atom, you have to have 8 electrons. So it also tells you how many electrons you have. 8. So, all right, let me ask you this. What would you do, what does every atom do with their first electron? Where does it put it? Which S? The first level, second level, third level, fourth level? Yes, they always put it in the lowest energy level, which is called the first energy level, right? And the only place you can put it in the first energy level is this kind of a weird probability zone called a s orbital. Now, so you can put, we know we can put 1 electron there, but you have 8, don't you? Can you put another one in there? And every orbital can hold 2 electrons. If I say 1s1, I could have put another one there, couldn't I? Because every orbital, this guy here, everybody look at me. Look right here. This can hold 2, this can hold 2, this can hold 2, 2, 2. So in the first energy level, in the s orbital, can you put 2 there? All right, now that means you have 6 more electrons, don't you? Where are you going to put the next electron? You can't put it in the first energy level. You know why? There's nothing left. You already put 2 here. There's nothing else to put in there. So you got to jump to you have to put them in the second energy level, which is further away from the nucleus. Now, in the second energy level, they always go into S first. They always go into S first. Now, how many can you put in there? 2. So you say 1s2. That means 2 of my electrons are in the 1s. 2 of them are in the 2s. Now, that's 4, but you had 8, didn't you? You got to tell me where the next 4 go. You can't put any more in that 2s. But look at all these other spaces. Look at all these other orbitals here. They're called p orbitals. S orbitals, p orbitals. Got that? So I could put 2, 4. I have room for 6, don't I? I have room for 6. Look, I can put 2 in this orbital. I can put 2 in this one. I can put 2 in that one, couldn't I? So I'm going to say in the second energy level, I already put some in the 2s. So I'm going to go to the 2p orbitals. And how many do I want to put there? And you can only put 2 in each one, but I could put 2 and 2 and 2, so I could put even 4 in there, couldn't I? I could put 4 somewhere in here, couldn't I? Because you could put 2 here, 2 here, 2 here. I could put 6 in here. I don't have that many. Now, you know what's interesting about this? I'm going to stop here. And this, I really do need you to pay attention. I'm not sure why some of you look like you're a little more tired. On what did you do that make you so tired? Okay, so let's kind of get a little more alert. Okay, everybody be alert. There's a lot of vocabulary words in this chapter too. For example, this guy has 8 electrons. I got it. But there's another word that you're going to have. It's called valence electrons. Have you had that? I think in middle school they do valence electrons, don't they? Valence electrons are the outermost energy electrons. So watch. This is not your outermost energy level. The outermost energy level is level 2. So how many valence electrons does oxygen have? It has 8 total electrons. But of those 8, 6 are called valence electrons. And 2 of them are called core. And I didn't make up that name, but valence electrons, everybody's heard of those, but core electrons. So core electrons are ones that are not in the outermost energy level. Okay, so now here's what's the most important though. The chemistry, when I remember how we said elements like to gain electrons or lose electrons sometimes and form ions. Do you know that only chemistry happens? It never happens with the core electrons. It only happens with the valence electrons. And so this number here is kind of important. See where that's 6 right there? And if you look on the periodic table, and again, I want you to, one of my favorite things to teach is this, because you can make connections. You have to make connections. You don't have to make them right now, but sometime today or Monday, make these connections. Now take a look there. Notice that this number 8 tells you that it has 8 protons, and if it's a neutral atom, it has 8 electrons. That's easy. But notice what Roman numeral is above this whole column, every one of these. What Roman numeral is above that? 6A. Why would they have a 6 there? Because everybody in this column has 6 valence electrons. And you'll find out later that putting 8 in your valence electrons, that's what they'd like to do. And oxygen is 2 away from doing that. It only has 6 in its valence electrons. If it could have 2 more electrons, it would stop reacting. And that's why every time you wrote a compound with oxygen, what did you put for oxygen?
-2.
You put -2, because it has a tendency to want to gain 2 more negative guys. And that's where that's coming from. Matter of fact, everybody in that column has 6 valence electrons. Oh, -2, -2, -2. Get that? Let's do another one. Let's do another. Yes.
Does that explain why the noble gases are inert? Is it because they have all 8 of their valence electrons?
Except for helium, they all have 8 in their outermost energy level. 8 is a very special number to says, I'm going to stop reacting if you put 8 in my outermost energy level. Here's another reason. Watch. If you're an atom and you already have more than 4, 4 is half of 8, isn't it? What if you're more than halfway to 8? What are you going to do? I'm going to gain 1, 2, 3. What are you going to do? I'm going to gain 1, 2. What are you going to do? I'm going to gain 1. Oh, that means you're going to be -1, -2, -3. You see? And what if you have less than halfway to 8? Less than halfway to 8. I'm going to lose 3, lose 2, lose 1. But I'm less than halfway to 8. It's easier for me to lose. So those will become metals. You see? Those are the metals. They all have either going to lose 1 or 2 or 3 electrons. And nonmetals are going to gain 1, 2, or 3. Let's do another one and see how it goes, all right? What's the next element after oxygen? Okay, let's do fluorine, all right? Now, everybody in here, I really want to see your hand on a pencil. And I want to see you doing this, all right? You can't come up later, I don't understand. Why? Because you did something. Couldn't it be me? I want you to, if you make a mistake here, that's fine. But at least you're trying it. All right, let's pick, I don't know. Hey, John, you want to help me? John, how many electrons does fluorine have? Okay, what would you do with 9 electrons if you're a fluorine atom?
Or one has,
Say it again?
one has two,
Yes?
and then two has two,
Oh, yeah.
and then I had two P5.
Okay. And wow, look at that. I think you got this. Look at hey, look now. It has 9 total electrons, but how many are valence? Outermost energy level. That includes 2s and 2p, doesn't it? And so look at how many valence electrons do you have? 7 valence electrons. And all chemistry happens with valence electrons. And so, wow, 7 valence electrons. How far away are you from having 8? Ooh, so what are you going to have a tendency to do? React by doing, why do you want to react? I want to do what? I'd love to gain 1 more electron. And if I did, I'd become not F, I'd become F minus 1, wouldn't I? Because I had an extra negative electron. And that's why fluorine likes to form a negative 1 ion. Yes?
How many, like, you could do like P5, how many can you go to?
Okay, good question. Excellent. It just so happens that in an s orbital, you can only put 2, and there's only one s in the first level. There's only an s in the second. But how many different ways can you be a p orbital? 1, 2, 3. So I could put 2 electrons here, 2 electrons here, 2 electrons here. How many is that? 6. Now, watch what happens. This is interesting. Very interesting, okay? I want you to look at the second energy level. Ready? You have 1s and 3 p's. How many orbitals are there in the second energy level? How many orbitals? Uh-oh, I lost you. How many orbitals are in the first energy level? 1. It's an s orbital, right? How many orbitals are there in the second energy level? What? Somebody said it. 4. And every orbital can hold how many?
2.
That would be 8. So you can put 8 as a maximum number of electrons in the second energy level. How many can you put in the first? 2. How many elements are in period 1? 1s1, 1s2. That's done. How many orbitals in the second energy level? How many orbitals? Count them. How many orbitals? 4. How many can each orbital hold? How many is that altogether? 8. I'll put 1, 2, 3, 4, 5, 6, 7, 8. That's why there are 8 elements in the second period. Watch. Ready? 2s1, 2s2. Jump the ocean. What are you getting into now? Matter of fact, see this right here? This is called the S block. Everybody's putting, my laser right now. Dang. Everybody's putting 1 electron in the s orbital here, and 2 electrons here. I lost. You come over here and get in the p block. Ready? How many columns are there in the s? 2. Put 1. Put 2. How many p block elements are there? 1, 2, 3, 4, 5, 6. See that? There's 3 p orbitals, 2 apiece. That's 6. That's why there's 6 in that block over there. Okay, so what do you think? Are you okay, Saul? We're going to make another jump now. We're going to make another jump. First of all, I didn't do this. Some other people much smarter than me, they discovered this a long time ago. First energy level only has S. The second energy level only has S and P. The third energy level has S, P, and D. Now, again, just be careful. You're okay. You're okay. Now, look at the d orbitals. Those are weird, aren't they? I thought the p orbitals looked kind of weird. And so, what do you think electrons are doing in that d orbital? I don't know. Nobody knows. But I know there's 5 different ways to be a d orbital. Now, you might say, oh, this is so complicated. There's no pattern. There is a pattern. S, SP, second level, SPD in the third. How many orbitals can you be S? There's only 1 kind of S orbital, 3 kind of P orbitals, 5 kind of D orbitals. 1, 3, 5. See the pattern? All right, so let's see what happens here. Let's go a little further with this. Let's go to sodium. Okay, let's do sodium. See if you can do the electron configuration for sodium, all right? Is this getting better, Olivia?
Yeah, a little bit.
Okay, and we're gonna do it some more. We'll do it some more. We'll do it some more. John, you were a good parking attendant. You parked those cars really fast. You knew exactly where they were gonna park those cars, didn't you? Because he said it right off the bat. He said 1s2, 2s2, 2p5. Yep. Oh wait, I skipped it. I'm sorry. I skipped the noble gas. My fault. My fault. We need to do neon. Let's do neon, then we'll do sodium, okay? I'm sorry, I skipped one. All right, let me call on Eloise. Eloise, you're the parking attendant. How many cars are you going to park in the neon for the neon party? Oh, wait. How many electrons? Huh? 8? Wait, are you guessing? I'll give you a clue. Neon is number 10. And that means it has 10 protons and it has 10 electrons if it's a neutral atom. 10. All right, where are you going to park your 10 cars? Go. All right. Okay. Two P what? 6? What do you think? Is that what everybody has? Okay, now, we have 10 total electrons. How many of the 10 are valence electrons? How many are in the outermost energy level? 8. You're right. 8 is very special in chemistry. All these elements except for helium, he only has 2, so he can't put 8. Everybody else who has all these have something in common. They have 8 in their outermost energy level, and if you put 8 in your outermost energy level, you won't react. Hey, you want to gain? No. You want to lose electrons? No. You want to share? No. Well, you're not going to do hardly anything. You're right. That's what I call the inert gases, the noble gases. Okay, so I want to show you something here. Ready? If you're a noble gas, I don't care which one you pick, they're going to have 2 in the S and 6 in the P. Now, I'll tell you that these right here are in the second energy level. So the valence electrons for neon are 2s2, 2p6. That's 8 of them, right? What's down here? I'll do this one, krypton. Krypton's in period 4. Where are your 8 valence electrons? 4s2, 4p6. Let's do another one. How about argon? I'm in period 3. Where are your 8 valence electrons? 3s2, 3p6. They all have that in common. All the noble gases, except for helium, have 2 in the S, 6 in the P, whatever energy level that's in. Okay, so now, what's going to happen when you go past a noble gas? Can I put any more in the second energy level? Can I put any more electrons in there? 2 here and 6 there? I can't put any more in 8, can I? So who's the first element to need a third energy level?
Sodium.
And where do you find sodium? Aha! You're the first element in period 3. Wow. Let's do sodium now. Okay. Okay, let me call on Claire Hegler. Go. You're going to park how many cars with sodium? Okay, where are you going to put them? 1s2. Okay. Okay, uh-oh. No more space in the second energy level. And you might be saying, next question you might ask is there an S in the third energy level? What's the answer? Yes! There's an S in every energy level. Hee-hee! Okay, so is there a 3S? Yes. And it's going to go in there. So what are you going to put here? Oh, yeah. You have 11 electrons, right, Claire? How many of those 11 are valence electrons? Outermost energy level. Yes. And what's the Roman numeral above sodium? 1. Everybody here has 1 valence electron in an s orbital. 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. What? Whoa, what a coincidence. No, that's why the periodic table is shaped that way. You get that? All right, let's do another one. So this has 1 valence electron. Oh, you know what? We might as well talk about this now. Ooh, this is good stuff. This is some good stuff. If sodium wanted to be more stable, it could gain 7 more and have 8 in the 3rd energy level, couldn't it? That means I got to go find 7 electrons and steal them from people. I could do that. But what's another way to become stable electronically? What if sodium were to lose the 1 valence electron? How many would be in his outermost energy level now? He doesn't have a 3rd energy level anymore. He lost that electron. How many would be in there now? How many? 8. You know what? He would be like neon's electrons. He's not neon because the nucleus is not like neon. But guess what? If you lose 1, your electrons are just like neons, and we know that's stable. So what does sodium tend to do? Lose 1 negative electron and become what kind of an ion? A +1 ion. Whoa! Now it's coming together. Before you just told me, sodium, everybody in column 1's +1. Okay, I'll do what you say. But now you know why. Let's do another element, okay? Isabella, I haven't called you. What's the next element?
Magnesium.
Okay, magnesium. Here we go. Give me how many cars are you going to park here?
12.
Okay, tell me where you're going to put them.
I'm gonna do 1 S2,
Yes?
2 S2,
Yeah.
2 P6,
Oh, yeah.
3 S2.
3s what?
2.
2? You're right. You are right. Isabella, how many valence electrons does magnesium have? Every atom of magnesium has how many valence electrons? How many? How many valence? The outermost energy level. How many electrons in it? Yes, 2. 2. Everybody get that? All right. So guess what? If it could gain 6 more, go steal 6 electrons from somebody, you could be stable. That'd be 8. What's another way to be stable? Wow, I'm not even halfway to 8. So I'm not going to gain 6 more to make 8. I'm going to lose these 2. And if I lose 2 of my negative electrons, then how many are in my outermost energy level? 8. Yeah. And so guess what? Both of these people, both these elements, I'm going to lose 1, you're going to lose 2, and when we're done, our nucleus will still be a sodium nucleus or a magnesium nucleus, but guess what? Our electrons won't. My electrons, I won't have 12 electrons, I'll only have 10. And you know what I'm going to do with 10 electrons? I'm going to put in the same place that neon did, and I'm going to stop. I'm going to be so stable that I'm not going to do anything. Once I lose 2 electrons, I'm done. Do you ever wonder why sodium only wants to lose 1? I don't know, because you said so. It's only going to lose 1. Because the remaining electrons are going to be very stable, and they're going to be like neon, and I'm not going to do anything else, period. All right. I'm getting a little excited. Okay, a little bit. Yeah, lunch is, a little bit, a little excited. Okay. Now, this is where you're trying to make connections from stuff we did even in the first semester. Now, here's where it gets a little different, okay? Are you ready? Will, you ready if I call on you? Even if you stumble through it, would you try it?
Somebody else get one more time before I answer.
Okay, so you tell me who to call on. Who am I called on? Win? I haven't called on Win, have I? All right, let's see if Win did. Win, what's the next element?
Aluminum.
Okay. Oh, aluminum's that's way over that ocean, isn't it? Ooh, something's gonna happen here. How many electrons are you gonna park?
There's 13.
All right, say it again.
There's 13.
Okay, where are you gonna put them?
So you're gonna do one S2,
That's where you put 2 of them.
and then two S2,
Oh, yes.
and then two P6,
Oh, yeah.
and then
Wait, I'm gonna stop. 6 plus, that's 10.
so and then three S3.
Oh, yeah. Ooh, it's 12.
Or
Don't you put another one there? Huh? Huh?
three.
You'll put another one in the S? Huh? Hmm? 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 How many can you put in any orbital?
Oh, two. So then you do D1.
What? That's it?
You do one D, or no, 4D1.
Wait now. You had one, all right, you're getting close. You only have one more electron, right? And they didn't draw the picture here, but in the third energy level, there's 3s, and there's also PPP. They also have 3p, all right? So after you get down to 3s, you're still in the third energy level, but you can't put any more in the s orbital anymore. You have to put it in the what? P.
So only one.
All right, let's count them up. Is that 13? That's it.
So what were the D's?
We'll get there.
Okay.
A good question though. If I can get you to understand S and P, then I'll go to D. Okay. If everybody in here understands S and P, then I'll talk about D. You did a good job. You for a while you thought you could put 3 in the S orbital. You said no, can't do that. All right. All right, Will. Are you ready? What's the next element? What's after aluminum? Huh? Silicon. Let's do it. How many cars you have to park? Okay, I'll help you. Look right here. Every atom of silicon has 14 protons. If it's a neutral atom, it also has to have 14 electrons. Okay, so you're going to park 14 cars, 14 electrons. Go. Ah, but you could put 2 there. It can hold 2. Huh? All right, 1s2, 2s2. Say it again. You haven't filled the second energy level yet. Say it real loud. Or say, I'm not sure. 2p what? Now, that could be the case. If there was only one p orbital, you'd be correct. But how many p orbitals are there? Look right here. How many p orbitals are there? 3. And each orbital can hold 2, can it? So I could put a lot more in these p orbitals. I could put more in there. I can actually put 6 in there, can I? 2, 2, 2. So watch. What are you up to now? 2 plus 2 is 4. Plus 6 is 10. And how many cars you have to park again? 14. I got 4 more to go. You know, you already filled the second energy level. You can't do any more. You better go up to the next level. 3. And the question is there an s orbital waiting for me in the third energy level? Yes. Every energy level has an S. All right? Every energy level except number 1 has 3 p orbitals. All right, go ahead. 3 what? 3s. How many? Every orbital can hold 2. I'm going to put 2 there. Ooh, you're getting close. You're getting close. How many more do you have? Wait, here's how you count them. Look at this. Look at this. 2, 4, 10, 12, and you said you had 14. You only have 2 more to park. Okay. Now, Will, How many of these 14 electrons are called valence electrons?
Oh, wait, no, it's 2, right?
Okay, the outermost energy level. Here's level 3, here's level 3. I have to count both of these, don't I?
Oh, okay, so
How many? How many valence electrons? Here, look right here. The third energy level is his outermost energy level. He has 2 here and 2 here. So how many valence electrons? Okay, now, what Roman numeral is above silicon? Well, the Roman numeral. Does this one have Roman numerals on? This is called the 1 through 18 system. This has both systems on it. I like to use the Roman numeral system for first year chemistry. So what Roman numeral is above silicon? Can you see that? It's an I and a V. Okay, good. So anyway, and guess what? Everybody in this column has how many valence electrons? 4. Huh. Can I show you a little trick here? He said 3s2, 3p2, didn't he? Watch. 3s1, 3s2. 3p1, 3p2. This right here is called the S block. You know why there's only 2 columns in the S block? Say it. Right, and if you're here, you put 1 in the S. If you're here, you put 2 in the S. See that? If you're found in the first 2 columns, that means your last electrons are in the S orbitals, aren't they? Like 1s, 2s, 3s, 4s, 5s, 6s. See it? And then you jump over here to this other block. This other block has how many in it? How many in this block? 6. Why 6? 3 orbitals, 2 electrons per orbital, 6. And guess what? Everybody here puts 1 in the P. P1, P2, P3, P4, P5, P6. Whoa, oh, oh. And if you add the S and the P, here, 2 S's and 1 P, that's 3 valence electrons, Roman numeral 3. How about 2 S's and 2 P's? That's 4 valence electrons. Yes, yes? All right, watch this. Can I give you a hard one? Let me give you a hard one, okay? Let me give you a hard one. Give me the electron configuration for that. Give me the electron configuration for F minus 1. Remember the grid game? F would have been 9 electrons. What's F minus 1? What does it mean, F minus 1? And I know your whole life, minus meant to lose something. But in the world of chemistry, if you're a negative electron, you have extra electrons, don't you? That's what made you negative. All right, so once we do this, we'll be done. Ready? Watch. I'll bet Andrew can do it. Andrew, give me the electron configuration for a fluorine minus 1 ion. How many electrons is it going to have? Say it. Yes. Go ahead, go. Yes. Now, fluorine's nucleus is still fluorine. But guess what his electrons are just like? His electrons are just like which one? The closest noble gas to him, right? Wow. That's a great, all right. Here's what I'd like to do. You should be able to do a lot of your homework questions now. We've done a lot here. And so I would like you to not wait. Please don't wait till the last minute to do those. Did I say the test on Friday? Is that what I said?
With the homework questions, what sections are we in?
Well, we never go to the additional problems. So let me see what page it's on, you mean?
It's on page 337.
All right, let me find it.
We're not going through, we're not.
You don't start until you get to first of all, it says questions and problems. That's on,
Questions and problems and-
yeah, questions and problems. You do the odds and you don't go to the additional problems. So there'll be about 70 of them altogether, but some of them are like, what's the configuration of, you know, you can do them kind of quickly. Hey,
I have a question. I don't understand why neon like has like 8 valence electrons and
how much, say it again? You don't-
I understand how the neon has like 8 valence electrons and then once you get
Okay, now,
down,
so here's the first energy level, and here's the second energy level. See, both of those are in this. So if I say the outermost energy level, I didn't say orbital, did I? The outermost energy level. Here's outermost energy level is number 2, isn't it? Level 2. So I'm not going to look at you. Well, how many electrons are in the outermost energy level? 8. We can pick another one. Here's one. What's your outermost energy level? The second level. Okay, I'm not going to look at you. How many valence electrons do you have? 7. And what's the Roman numeral above fluorine?
7.
Oh, that's pretty good. Let's pick one a little harder. Here's sodium. First level, second level, third level. The outermost energy level is number 3, isn't it? How many electrons in his valence?
1.
And where do you find it? What's the Roman numeral above them? Whoa. Whoa. What's the Roman numeral above magnesium?
2.
Has 2 valence electrons, right? How about aluminum? Outermost energy level. See that? Ooh, 3. So your valence electrons are always S and P electrons.
Thank you.
Very good. What do you think? Feeling better?
Yeah, I'm feeling a little better. I was just gonna ask if I could do the extra credit with the spectrum. this
Yes.
weekend.
All you do is you can, if you want to wait till the end of school and pick it up. I ask you not to try not to have anybody sit on it or break on it because they're kind of fragile. But yeah, you take that and you could go to the gym before you left. Now, what I would do is if you could somehow make a little bar, and I'm not sure whether your ruler goes 400 to 700 or 700. I don't know which way it goes. When you look in there, did you see a little ruler yesterday?
I was confused. I couldn't quite figure out how to work it.
Oh,
yesterday.
you better go get it because if you're going to take it home and you don't know how to use it,
I was gonna ask you too.
yeah, just bring one to me right now. Yes.
I was just gonna say, could you do the F-1 problem again?
Okay.
The last thing.
So what you have to do, just like the grid game, F didn't give you the same as F-1. F normally would have, fluorine would normally have 9 electrons. But what's F-1 mean? It means you have 1 more electron. So you actually have 10 electrons.
Okay.
And where would you park 10 electrons?
Oh, so then you do 1s2.
Uh-huh.
You do.
And there they are.
Yeah.
Now what's interesting, the nucleus still has 9 protons, so it's fluorine. There's still fluorine, but guess what he did with the electrons? Ooh, they're in the same configuration as neon. That's why he'll only gain 1 electron. He won't gain 2.
Yeah. Oh, so there are 8 valence electrons on that one.
Yes.
Oh, okay.
Yes.
Okay.
Okay, so let me show you him. What you're gonna do is, there's a slit. You want the light to go in this. Oh,
Okay, I got that part, but I
Oh.
wasn't seeing like the color. I kept seeing the
okay.
rainbow.
I wanna make sure nobody, yeah, it's a rainbow.
Okay, so you're not
see-
just seeing one color.
Well, no, if some kinds of light, like right up here, here I'm getting kind of a rainbow, but they're kind of like bars. So just look at that light there. Do you see? It's kind of a rainbow, but it's in a bar shape. When I turned on that bright light, didn't you see like everything?
Yes.
Okay, now-
Maybe I was doing it right. I just didn't understand.
So now, what I like to do is when you go in the gym, you got to make that slit go right at that bright light, okay? And then you want to write down what you saw, and I forget what are the numbers on it? Say 4, 5, 6, 7.
Yes.
Okay, so 4 is 400 nanometers, 500 nanometers, 600 nanometers, 7. To get extra credit, I would like you to draw where you saw these bars.
Where I saw one.
Like, let's say you saw one really close to 4 when it was red. I mean, it was violet, sorry, it was violet. Well, maybe you saw one here that was violet, and maybe you saw another one next to it that was violet. Now, again, you want to do it like when you get to those lights, okay?
Okay.
And then you would just make some lines. You'd say, that was a violet line, that was a violet line. I saw green, maybe I saw green here, and maybe I saw red, maybe I saw 3 reds. See that? And that would be like the gym lights.
Okay.
And then you'd
I
have a
do-
street light.
Okay. Yeah, I'll try
And
find a
if you can
couple
find a bright street light, and then maybe a neighborhood has dingy looking ones, And then, I know the grocery store is gonna be a little weird.
No, I'll do it. I don't mind.
But find the lights that you know are shining on the meat and see if you can,
Okay.
see if you can get it on that. You might not be able to get it to it. If you could get like 4 or 5, that would be a great extra credit. So you just go home, make a little bar, make it like a ruler, 4, 5, 6, 7, okay? It's gonna be before 4 and 7. You're not gonna see, you won't see past 7.
Okay.
And I think that'd be a great extra credit project.
Okay, thank you.
Okay,
So I just bring this back to you over the week.
yeah, and if something happens, you say, I didn't quite finish it, just let me know.
Okay.